This video is going to look at some more complicated application problems. It's going to primarily deal with things coming from 2.7 and 2.8, which talks a lot about rational functions. One example you might see is talking about the concentration of different mixtures that you might see. In this case, it's an acid solution. So the question here is how much pure acid must be added to 50 milliliters of a 35% acid solution to produce a mixture that is 75% acid. So you already have this one mixture, you have another container that has pure acid in it, you want to somehow combine the two to get something that is 75% acid. That means 3/4 of it are acid and 1/4 would be just pure water. And you put them together, you get a 75% mixture. That's kind of the idea. We're just not starting with pure acid and water. We're starting with something that is 35% acid and then pure acid. So it makes it a little bit more difficult when you have these other mixtures. So to begin, let's start at the beginning. What did we have of pure acid at the very start of this problem? Let's call that X. Okay, and then I also want you to realize that the way we come up with the percentage is you think of how much pure you started with and you divide it by the total amount. So if we had a 25% solution, that means out of, let's say, 1 gallon, out of 4 gallons, maybe 1 gallon was pure, 3 gallons are water, total of 4, and that means that 1 to 4 gets us that 25% solution, 1 out of 4. So that's how I would begin to think about this, is to say, let's name a variable, and in this case, how much did we have at the very beginning, and let's get the overall equation. I think this is kind of a key thing here. How do we even think of a percentage? Okay, so at the very beginning, we have 50 milliliters. Okay, we know that if I take whatever amount of pure acid I had at the start and divide by the total volume, I'm supposed to get 0.35, okay, or 35%. Well, that's pretty easy to solve for X. I can just move things around and I get 17.5. So there was 17.5 milliliters of pure acid. That means that, 32.5 milliliters of water. I put that together, I get a total of 50, but that also gives me that 35% solution. Okay, so there was 17.5 milliliters of pure acid. Okay, what we want to know now is how much pure acid would I have to add to this to get 75% solution. So let's add another variable here. We already figured out how much was there at the beginning. Let's say that Y stands for the amount of acid, the pure acid that I add. So this is the situation at the very beginning. I want you to think in the situation, where would Y belong in this kind of percentage equation? So remember, the top stands for the amount of pure. I had 17.5 at the beginning. 50 is my total volume. If I'm going to add pure acid, it's going to apply to the pure amount, and it's also going to apply to the overall volume, the overall amount. So I'm just going to add Y to top and bottom. It's part of this overall numerator and denominator in this equation. If I was trying to dilute the percentage, if I was just adding pure water, then I would just add it to the bottom, because the amount of pure acid in this overall mixture would not change at all. Okay, so this is my equation. I want to know what Y has to be. We're going to graph it. So you would simply enter this into Y1. You would enter this into Y2. So this is going to be a little complicated. You have to make sure you use parentheses appropriately for division, especially on older calculators. And the tricky thing here is, as you type this in, you don't type in a Y value or a Y variable, you type in X. So the X on your calculator really stands for the Y in this problem. It's just a change of variable. Okay, you would get this graph. Again, the X-axis stands for the Y values in our problem, the amount of pure acid that we're adding. And the Y values, the Y-axis stands for the percentage, right? That's what 0.35 and 0.75 stand for. So we're graphing these two things. When I look for my intersection, it's going to occur somewhere around there, and the coordinates are 80, 0.75. So I need to add 80 milliliters of pure acid, and that's going to get me my 75% solution. Okay, that is your answer. We will pause the video right here.